Before you get started on this teacher talk, we would like you to watch the star shade video on the Futures channel. Okay, if you're not sure how to get to the Futures channel's videos, you need to go into modules, and at the very top there should be a link to the Future channel's videos. All of the videos are in alphabetical order, so please scroll down. You're going to scroll down to T because it's under the star shade. So set 1 here is talking about an airplane. It tells you whenever we start this, we always want to start with a diagram. So we know we're going to have a diagram like this. We have a path of the plane, we have the ground distance, and the elevation that we're looking at there. Okay, so we're going to label the information that they've given us. They told us that the angle of elevation is 18 degrees to the ground, which means if we're on the ground looking up at the airplane, that's 18 degrees. They want us to find the ground distance, so that means that green distance down there is x, and they say it's traveled through the air at 2,500 meters. Okay, so with the side links that we have there, we're given the hypotenuse and we want the adjacent. So we're going to go ahead and set up a cosine equation. And to solve for x there, you'd multiply 2,500 over, rounding to the nearest meter, you get 2,378 meters. Okay, then it's important to pay attention to the fact that they also asked us at this point how many meters off the ground, which is another way of saying what's the elevation of the plane. Okay, so elevation is that blue line there. So given we want the y value and we're given the 2,500 meters, we're going to use a sine function because that's opposite in hypotenuse. And again, to solve for y, we're going to multiply the 2,500 over, and we end up with 773 meters. On this example here, we're going to be looking at, they told us that the telescope requires an angular separation of 0.00005 degrees. That is an extremely small angle there. Okay, and if we're looking straight at the sun, we have a right triangle. And they're asking for what's the distance of the planet, which would be our other side length there, which is really ended up being the hypotenuse, the way that we have it drawn. And they tell us that the planet is orbiting its sun, which means the distance from the planet to the sun is 93 million. So given the two side lengths that we have, in comparison to that angle, we have opposite and hypotenuse. So we're going to, okay, sorry about that interruption. So if you're going to solve for y here, again, we're going to switch the y and the tangent, and we'll end up with 1.066 times 10 to the 14th miles. Okay, your calculator should be giving you scientific notation, and again, make sure you label it with miles. Then on this last example here, we're going to start with our right triangle. It's extremely important that we label our angles correctly. They tell us that angle C is the 90 degree, and then it makes the other two angles have to be A and B. So they say if the tangent of B equals 6 over 7, okay, tangent is opposite over adjacent, so they're telling you that the side opposite of angle B is 6, and the side adjacent to angle B will be 7. They're asking us for sine of A. For sine, we need opposite over hypotenuse, and we don't have the hypotenuse right now. Okay, so we need the hypotenuse. So we're going to go ahead and set up our Pythagorean theorem. H squared equals 6 squared plus 7 squared, and we end up with h equals 85, square root of 85. And then lastly, for the sine of A is going to be opposite over hypotenuse, which is 7 over the square root of 85. That is not in correct form. Okay, so we should need to rationalize the denominator by multiplying the top and the bottom by the square root of 85. And we end up with sine of A equals 7 square root of 85 over 85.